Focus, ladies and gentlemen. For the second lab here, we're going to look at data table 2. The volume of water turned out this time to be about 46. I didn't get exactly the same amount, but we're going to start the same way. So we're going to put that in here, and we're going to weigh it. So the mass of the flask and the water this time, the mass of the flask and the water is 167.32. 167.32. That's the flask and the water. Now, there are some other things that we need to add to this. I can't just drop these in and then try and put a balloon over it, because what will happen? I can't just drop these in and then try to put the balloon over it.
Put the Alka-Seltzer in the balloon.
I'll put the Alka-Seltzer in the balloon. Hey, this guy's thinking already. So I'm going to go ahead and take the same 2 tablets I had before, and I'm going to break them up. Well, not the same 2, but I'm going to break them into quarters here. And then I'm going to put them.
The crack and like dust particles.
What?
The little tablets of the crack, make crumbs and stuff.
Yeah. But that's why we didn't weigh them first, because whatever goes in the balloon is what we'll weigh. So I'm going to go ahead and try to cram some of this stuff in here. Shouldn't be this hard. There we go. That one goes in there. 2. Now remember, we're doing this way because we don't want to lose any of the gas. So we want to make sure the container is closed before we do this. So then we can weigh the mass of the balloon and the Alka-Seltzer together. And what this is 10.34 grams. So when we put all of this together, our overall mass should be 177.66 grams. So let's see if even after the reaction, that's what we still have.
Why not?
It should be close. We'll see how it works out. So now that those are in there, see if we can get these to come back out. All right, and so now you can go ahead and observe the reaction. Now you should see and expect what's about to happen here is that the balloon will start to blow up. The balloon's blowing up because we're showing that in our last experiment there was a gas escaping. Hopefully this doesn't just pop off. Go ahead.
Even if you added heat, wouldn't that create the gas to dissolve faster?
If you added heat, the solid would dissolve faster, yes.
Yeah, you're supposed to use warm water, I thought, anyways.
Probably. But the reaction is just slower at this point. The amount of products produced is the same. And so we're going to go ahead and let all of this dissolve, just like we did before. I hope not. But hopefully, we've shown now, if we can measure this quantitatively, hopefully we can show that
Is it gonna blow up?
it was the gas that escaped that caused the difference in our first one. I'm just hoping the balloon doesn't fall up or fly out. Almost done. There we are. So now, we go ahead and weigh this. Here. Not on off and tear is what I want to do. And let's hope we end up with something close to 177.66. If not, there's an error in our experiment. What we ended up with was 177.59.
Good news.
So 177.59. Now, to be honest, that could be, you guys have used balances before. They're always slightly off or slightly errored there. But we're way closer this way than we were this way. Okay? Way closer this way than we were that way. And so what we're showing here is we're showing quantitatively now what we looked at qualitatively the time before. So Elephant's toothpaste, we had effervescence. We said, oh, a gas was created. We said, oh, there was a color change. Those were all qualitative. This one, we did the same thing, but now we actually captured the gas. And we measured the gas based on math. We know that if I take this minus this, I can tell you how much gas was produced. So in science, there's qualitative data, there's quantitative data, and all of it comes from